Well, this lesson is all about similar triangles. And one way of producing similar triangles is to do a dilation from some central point. All right? Often we've used the origin, but it doesn't have to be the origin. It can be any random point. And so let's go ahead and practice doing a dilation from point O here without a coordinate plane, without graph paper. So you're going to need your compass and a straight edge to get this done. Now, because I'm trying to do this virtually using a virtual compass, I'm not going to be able to do this right on the homework here, but I think I can come up with something similar enough to give you the idea. So just remember, we're dilating each triangle by a scale factor of 3. All right, that means here's the idea right here on the picture. Okay, here's what we're shooting for. Look at point A, for example. If I measured this distance from point O to point A, then if I want to do a dilation, scale factor 3, then I need to go 3 times as far. So right here, this would put me dilation scale factor 2. Okay, but I need to go even further than that. If I go, well, I'm going off the camera now, but if I go 3 times as far, then that's where my new point will be. Okay, can I move this? Skirt. Okay, so my new point will be somewhere about like that. I'm going to be more precise with this, but I just want to give you the idea. So here is the original. If I go that same distance again, that's dilation 2. Okay, maybe I'll put a little mark here or something. If I go that far again, can I pick it up again? If I go that far again, that'll be scale factor of 3. Okay, can you see the distances that I'm talking about? Look at this. Here's the original. Here I've doubled it. And here I've tripled it. Okay, so this would be like my B prime. And this is my A. Whoa, moved my whole TV. This will be my A prime over here. And similarly for the C prime, all right, if I go right here, that's the original distance. So if I go out to here, and I'm just estimating right now, then this would be about double. That would be a scale factor of 2. But if I go that same distance out again, then that would be my scale factor of 3. So this would be my C prime. And then if I connected all those points, okay, this is always tricky. Can I get it? I'll give it one more try and then I'll pause the camera. Oh, it did it. Alright, if I went from A prime to B prime to C prime and back again. Okay, that triangle, this pink triangle, is going to be dilated by a scale factor of 3, with O being my center of dilation. So that's the idea. Now, I wasn't using any measuring device. I was just estimating. And it came out pretty well. If I do this perfectly, then the sides of the original shape and the sides of my new shape should be parallel. And you can see it's pretty close. But now let me go back and show you with a compass. Alright, so let me see if I can demonstrate what you should be doing with your compass and your straight edge. If I want to take this triangle and dilate it, scale factor 3. Okay, so what you can do is first take your straight edge and you can just draw 3 lines. Alright, just stretch them on out there, starting from your center of dilation, and each line is going to go through your vertices there. So just go out pretty far, because you want to make sure that it's more than triple, since we're doing scale factor 3. So these are our guidelines. Okay. And one more. Alright, I'm being careful to go right through the vertex here. And I want to make sure it's more than triple. Okay, so those lines will guide me. Now it's time for the compass. Let's see, let me keep in mind what color I may want to use. I think I'll use black for the compass. Okay, so I'm going to use the compass. I'm going to put it at the center of dilation. Alright, and I'm going to stretch it out to my first vertex. Okay, now I'm just going to use this as a measuring device. So right now, okay, I didn't mean for that to move yet. Alright, it's at the first vertex, I said. So right now it is measuring the length from the center of dilation to my first vertex. So if I go that same distance out, okay, if I were to mark right now, okay, then what you're looking at right now, that would be scale factor 2, alright, because I've doubled the distance. But I want scale factor 3, so I need to go out even once again and mark again. Okay, so now it is triple the distance right here. So I'm just going to do that 3 times. So now I'm going to come over here and measure the distance with my compass. Alright, if I go to here now, then if I were to mark right now, that would be, I've doubled it, that would be scale factor 2. But since I want to triple it, I'm going to come up to here. Now I'm looking at scale factor 3 right here. And I'll do that one more time with the third vertex. First I just measure it, then I move it. Okay, right here, this would be scale factor 2, but I want scale factor 3, so I'm just going to move it one more time. Okay, so these final marks here represent scale factor 3. Alright, single, double, triple. So then all you have to do is take your straight edge, okay, and connect those new vertices. So it should go from here to here. Okay, I kind of missed on that last one. Let's see, can I just undo that one? Alright, it's a little bit better. Okay, so this red triangle should be the dilation of the blue triangle, scale factor 3. Alright, and notice when you're doing a dilation, you are producing similar triangles. Every side is going to be 3 times as big as the original, and all the angles are the same, and notice that all the sides are parallel, parallel, parallel. So that's what you should be doing. Alright, let me see if I can figure out a way to do this with Microsoft Word here. So if I want to dilate this with scale factor 3 from center of dilation O, then maybe I could start by marking off the distance from O to A. Okay, so that is the distance that I need to triple. So maybe if I can just cut and paste this, then it will stay facing in the right direction. So if I move it here, just end to end, okay, so far I have doubled it. And you know what, maybe it will work even better if I change the endings. Alright, maybe if I make it end in a circle. Whoa, that's kind of a big circle. I'm going to go with it though, because I kind of like having a circle there. So far, I've doubled it. So if I just cut and paste this one more time, then I should have tripled it, yes? Okay, so now I have tripled it. So this should be the location of my A prime. Okay, right here. I'm taking it and now of course you would do this with your compass the way I showed you on the previous problem. So make sure you watched the previous problem before you do this one. Alright, use your compass. So let me do that again. So now I'm going to go from O to B and see what I get. So if I go from O to B, alright, you can see there's my original length. So if I copy and paste this, if I go to here, now I have doubled it. That right there, that's scale factor 2. But I'm not satisfied with that. I want scale factor 3 because that's what they told us to do. So I'm going to copy it again. So single, double, triple, this would be the location of B prime after a dilation scale factor 3. So if I just do that one more time, I should be good to go. So I'm going to go ahead and measure from O to C this time. Alright, so there's my original distance. If I copy and paste it, that is going to show me where scale factor 2 dilation would be, but I'm going to copy and paste that one more time. Now by tripling it, I'm looking at scale factor 3. So this would now be the location of C prime. Now this is so big, I'm gonna have to zoom out a little bit here. Okay, can I get them all on the screen at once? Alright, so there's A prime, B prime, and C prime. So my new triangle, alright, this often doesn't work out very well, but it's working today. So A prime to B prime to C prime and back again. Where is it? Okay. So that is going to give me my triangle. Let me just fix that up a bit. Alright, so there it is. So this is a nice picture of a dilation of the blue triangle will give me the pink triangle, scale factor 3, center of dilation O. Alright, of course you cannot copy and paste segments like that, so your way of doing that will be to use your compass and measure distances and make marks along the guide. We'll go back and watch that video. Okay, so that's how you do a dilation from a center using your compass and straight edge. Now, let's get back down to some good old-fashioned algebra. These two polygons are similar. I guess we were supposed to find x and y. Okay, oh, here we go. The scale factor is what, and what's x and y. So, okay, I think we need to decide what corresponding sides are. Well, we have a short and a long, okay, and then we have a short and a long. So, for example, the 18 and the 16 are both long sides, so they're definitely corresponding. All right. By contrast, the 8 and the x, those are both short, so they are corresponding as well. So let's go ahead and find the scale factor. If I take it as the left parallelogram, if I take that as being the original, the pre-image, and if I take the right one as being the image, okay, then if I want to find the scale factor, I would do the second one, and for some reason I like to call the scale factor k. The scale factor would be the second one divided by the first one. Okay, and of course you can see it's shrinking a little bit, so this makes sense. This is going to reduce, yes. These are both even, so this would be 8 over 9 if I divide both of these by 2, 8/9. So that is the scale factor. Okay, all right, if you look at this as the pre-image and this is the image, we would see this as a dilation less than 1. It's shrinking a bit. At any rate, I can use that scale factor to find out what x is going to be. Okay, because if I take 8 and I multiply it by the scale factor, it should give me x. So in other words, all right, 8 times 8/9 should give me x. All right, well, 8 times 8 is 64, so that's going to be 64/9, and I'm pretty sure that does not reduce. Okay, so looking at my calculator, 8 times 8/9. Yeah, hold on. That's 64/9. So that is going to be the value of x, is 64/9. Let's see what that looks like as a decimal. It's 7.1 repeating. Wow, that's a goofy looking 9. That looks like a G or something. 64/9, which by the way is 7.1 repeating. Okay, anyway, what about y? Well, y is dealing with an angle, so I'm not going to multiply by the scale factor or anything. Instead, look and see that this is an obtuse angle. All right, 125 degrees, and this is also an obtuse angle, so these must be corresponding. So in other words, y plus 4 must equal 125. So if we simply subtract 4 from both sides, that should give us y. So y is going to equal 121. Okay, brilliant. So that's it for number 3. Okay, in this diagram, ABCD is similar to EFGH. ABCD, EFGH. Okay, great. The scale factor of ABCD to EFGH. In other words, pre-image, image. Okay? So look, all we need to do is pick one pair of corresponding sides. So we're going from 2 to 4. So that is a scale factor of 2. All right, it's doubling. So the scale factor is 2. Now the perimeter of ABCD. Okay, what's going on here? Can we find everything else? So this is going to be 2 and 1. All right. Clearly, we're looking at a rectangle here, or at least a parallelogram, but it looks like a rectangle. Now, so the perimeter of ABCD is just what we get if we add up all the sides. So this is 2, 4, 5, 6. So that's going to be 6. Okay. With a scale factor of 2, we would expect the perimeter of EFGH to be 12. That's our hypothesis. Let's verify it. Well, this is going to be 4, and then this will be 4, and that's 2, so this will be 2. So we have 4, 8, 9, 10, 11, 12, just like we thought. What is the ratio of the perimeters? Well, the ratio of the perimeters, if I do 12 divided by 6, okay, which equals 2. That's the ratio of the perimeters. Notice that's the same as the scale factor. Okay, what about these? ABCD is similar to GHIJ, okay, as you see here. So let's find the scale factor from ABCD to GHIJ. So in other words, we're going from this is the pre-image, and we're looking at this as being the image. Alright, so clearly this is shrinking. Now let's find out exactly what the scale factor is. So all we need to do is pick a pair of corresponding sides. In fact, let me fix my arrow here. We need to pick a pair of sides where we have both numbers. And really the only pair that we have, these two, we have both numbers for both corresponding sides. So 11 is becoming 5.5. So if you want to find that scale factor from that, you always do the image divided by the pre-image, right? The new divided by the old. So I'm going to do 5.5. Okay, that's a horrible 5. In my defense, writing with an electronic pen is trickier than it looks. It's amazing that it looks as good as it does, as much as it does. 5.5 divided by 11. This is going to give me the scale factor. Never leave it like this, though. 5.5 over 11, baby. Whoa, got carried away there. Alright, I see 0.5, which of course toggle 1/2. Alright, so the scale factor is 1/2. Okay, so that's going to be nice and easy. Oh, now they're switching it the other way around and saying, oh, what's the scale factor from GHIJ to ABCD? So if we look at it the other way, alright, and we look at it as this is the pre-image, and if we look at this as being now the image, then when we do the scale factor that way, we are always going to be doing the image divided by the pre-image. Okay, so in this case the image is 11 and the pre-image is 5.5 from this perspective. Now based on the fact that the other one was 1/2, we can guess that this is going to be the reciprocal. But let's follow through. Alright, 11 divided by 5.5. And oh look, it's 2. Fantastic. So going in that direction, the scale factor is 2. So if we look at it from left to right, it's shrinking. Everything is becoming 1/2 the original size. But of course, if we look at it the other way, everything is growing. It's becoming double the original size. Anyway, find the value of x. Well, okay, hold on. Colors. X and 8 are corresponding. This x should be double the 8, so 16. Alright, what about y? Okay, the 8 and the y are corresponding. Alright, this y should be half the size of this 8. So 4. Okay, now find the perimeter of both. Well, okay, so we just found that x here is 16 and y here is 4. Okay, and see how this is isosceles? That means this will also be isosceles. So 5.5. Alright, so look at the big one. Alright, the perimeter here, we have 16 plus 8 plus 11 plus 11. That's 46. Okay, now I don't have to add up the rest of these. I know that this trapezoid is going to be half the size of the other one. So half of 46 is going to be 23. Okay, so ABCD, that's perimeter of 46, and GHIJ is going to be perimeter 23. Find the ratio of the perimeter of ABCD to the perimeter of GHIJ. All right, well that's 46 to 23. So that's going to be, of course, 2. Alright, this video is long enough. I'm going to go ahead and end this video here, but there is more to come. There's more to the lesson. In the next video, we are going to deal with similar triangles specifically, and find some unknown sides and angles. I'll see you on that video.